Hello, students. Today we will study chemical properties of amines. First chemical property of amine is a laboratory test for amines. Under this, first is a test for amine as a base. So we can test in the laboratory why amines are basic in nature. We had already studied that primary amine, secondary amine, and tertiary amine and ammonia. All these are basic compounds. So this can be tested in the laboratory with aqueous solution. When aqueous solution of amine it is tested with red litmus paper, then this red litmus paper turns blue, that indicates these amines and ammonia that is a basic in nature. So consider this reaction with mineral acid. So if it is amines or bases, then it react with mineral acid and forms a salt. So this nitrogen containing 3 alkyl group, this is amine when treated with mineral acid like HCl aqueous solution, then it forms this nitrogen containing 3 alkyl groups bonded with hydrogen, and nitrogen possesses positive charge, so it is a substituted ammonium salt and the chloride ion is formed. So this is a substituted ammonium chloride. This ammonium aqueous solution and chloride when treated with NaOH aqueous in excess, then again it forms the amine NaCl and H2O. This water soluble amine that dissolves in aqueous HCl due to the formation of water soluble substituted ammonium chloride, which on reaction with excess NaOH regenerates original insoluble amine. So this test indicates the presence of amine. We can test this amine as a base in the laboratory. The second test for this amine as a basis, this is a diazotization reaction. This test is also called as a orange dye test, because in this test the color of product obtained, that is orange in color, that indicates the diazotization reaction. When primary amine is treated with concentrated HCl, then aqueous solution of NaNO2 is added. With cooling, this solution transferred to the test tube containing beta naphthalene NaOH, then formation of orange dye indicates the presence of primary amine group. So this primary amine group can be tested by using this HCl NaNO2 and beta naphthalene NaOH. This test is called as a diazotization reaction. Note this, all the solutions and the reaction mixture, these are maintained at 0 degrees Celsius throughout the reaction. Meaning is this reaction take place at low temperature. Now the next is the reaction that is called as a alkylation of amines. Second reaction of amine is the alkylation of amines. This is also called as a Hofmann's exhaustive alkylation. This reaction is also called as a Hofmann's exhaustive alkylation reaction. Here, when primary amine is heated with excess of alkyl halide, then it gives the mixture of secondary amine, then tertiary amine, along with this tetra alkyl ammonium halide. is formed, and this is called as a alkylation of amine, or also called as a Hofmann's exhaustive alkylation. Consider this reaction. This RNH2 is a general formula for primary amine when treated with Rx. Rx is alkyl halide. Here elimination of hydrogen halide take place and give R2NH. It is a secondary amine again treated with alkyl halide. That elimination of hydrogen halide take place and gives tertiary amine. Again tertiary amine react with one more molecule of alkyl halide. Here loss of hydrogen halide take place and give R4N plus X minus. This is tetraalkyl ammonium halide, commonly also called as quaternary ammonium salt. So if excess of alkyl halide is used, then we get tetraalkyl ammonium halide as a major product. And this reaction is exhaustive alkylation of amines. Here the tetraalkyl ammonium halide, they are also called as quaternary ammonium salts, which are crystalline solid. They are the derivatives of ammonium salt in which all four hydrogen atoms attached to the nitrogen, that is in NH4 plus, they are replaced by four alkyl groups. These alkyl groups may be same or may be different. So primary, secondary and tertiary amines consumes or uses respectively this 3, 2 and 1 moles of alkyl halide and get converted into quaternary ammonium salt. The reaction is carried out in the presence of mild base like NaCO3, that is a sodium bicarbonate, to neutralize large quantity of hydrogen halide formed in the reaction. If alkyl halide is a methyl chloride, then the reaction is called as exhaustive methylation of amines. Here the same example is taken. When methylamine is treated, methylamine is primary amine, is heated with excess of methyl iodide. It gives finally tetramethyl ammonium iodide, and the reaction is CH3NH2 is a methylamine. When heated with methyl iodide, it gives dimethylamine plus hydrogen iodide. In the second step, dimethylamine react with methyl iodide, second molecule, and gives tertiary amine, that is a trimethylamine, and the side product is hydrogen iodide. This trimethylamine react with methyl iodide, it gives tetramethyl ammonium iodide, and it is quaternary ammonium salt formed in the reaction. Then we will study this reaction number 3, that is Hofmann's elimination reaction. When tetraalkyl ammonium halide, just now we had studied what is tetraalkyl ammonium halide. It is heated with moist silver oxide. It gives quaternary ammonium hydroxide, which is deliquescent crystalline solid and strongly basic like NaOH or KOH. The quaternary ammonium hydroxide, on strong heating, it undergoes beta elimination reaction and it gives alkene, and this reaction is called as a Hofmann's elimination reaction. The least substituted alkene is obtained as a major product, and it is in contrast, in opposite to ZZEP elimination reaction. Here the example is taken, it is NNN triethyl propyl ammonium iodide. So this is N propyl group, then three ethyl groups are there. So it is NNN triethyl propyl ammonium iodide when treated with moist silver oxide, that is AgOH. Then here the formation of this hydroxide take place, that is NNN triethyl propan ammonium hydroxide. Here there are beta carbon, beta dash carbon and beta dash carbons are there, but here less substituted alkene is obtained, that is ethene, and the amine remaining is NN diethyl propyl amine, and this is Hofmann's elimination reaction. Next reaction of amine is a reaction number 4, and it is acylation reaction. So what is acylation reaction? Aliphatic and aromatic amine, primary amines and secondary amine, they undergo acylation reaction. Amines contain a replaceable hydrogen, that is positively polarized hydrogen on nitrogen atom. These hydrogen atoms are replaced by acyl group by using acetyl chloride or acetic anhydride, that is by using acetyl group. On reaction of amine with acetyl chloride or acetic anhydride, acetyl derivative of amine is obtained. It is also called as a amide formation, and amide is less basic than amine. Here acylation is nucleophilic substitution reaction, that is SN reaction. The reaction is carried out in the presence of strong base like pyridine, which neutralizes acid produced during the reaction. This is ethanamine, that is a primary amine, when treated with ethanoyl chloride, that is acetyl chloride, in the presence of strong base like pyridine. Then formation of this C2H5 NH2 CO minus CH3Cl. This intermediate is formed which loses HCl and forms N-methyl ethanamide. Here this example of secondary amine, that is CH3 and C6H5 group containing, it is N-methyl aniline. When treated with ethanoyl chloride, that is acetyl chloride, in the presence of pyridine, it gives this COCH3 group containing product that is called as a amide formation. So it is N-methyl N-phenyl ethanamide plus side product is HCl. So benzoyl chloride also gives the similar reaction. So remember this benzoyl chloride, that also gives the similar reaction with amine. The fifth reaction of ammonia, this is amines. It is an important reaction that is called as a carbylamine test or the carbylamine reaction. Now, what is carbylamine reaction? This aliphatic amine or aromatic primary amine, when treated with chloroform in the presence of alkali, then it gives the foul smell, that is offensive smelling products called alkyl or aryl isocyanide. These are commonly called as carbylamine, and this test is called as a carbylamine test. Now we will study, say, this reaction for carbylamine test. So primary amine is RNH2, general formula, when treated with chloroform having formula CHCl3, when heated with 3 molecules of KOH, then it give RNC, that is alkyl isocyanide plus 3KCl plus 3H2O. Here alkyl isocyanide formation that indicates the carbylamine, and this test is called as a carbylamine test. The sixth reaction of amine is reaction with nitrous acid. The formula of nitrous acid is HNO2. It is unstable. It is formed when NaNO2, that is a sodium nitrite, is treated with HCl. Primary, secondary, and tertiary amine react differently with nitrous acid. That is, it is a distinguishing test between primary amine, secondary amine, and tertiary amine. The reactions of only primary amine we will consider here. So the nitrous acid is an unstable compound, hence it is prepared in situ by adding aqueous sodium nitrite in hydrochloric acid already mixed with substrate, that is amine. So aliphatic primary amine on reaction with nitrous acid form aliphatic diazonium salt as very unstable intermediate which decompose immediately by reaction with solvent water, and the corresponding alcohol is formed as a product on reaction with nitrogen gas is liberated. So here RNH2 is a primary amine. When treated with nitrous acid at 273 to 278 Kelvin, NaNO2 and HCl is added to generate HNO2. Here the intermediate is Rn2 plus Cl minus. This is alkyl ammonium chloride. When H2O is added, we get ROH, that is alcohol, plus side product nitrogen gas and HCl. This is for aliphatic amine. Now for aromatic amine. Aromatic primary amine react with nitrous acid to form diazonium salt, which reasonably stability at 273 Kelvin. Here this is aniline, that is a benzene ring bonded with NH2. Primary aromatic amine react with nitrous acid. Again nitrous acid is generated by using sodium nitrite and HCl. Here we get the benzene diazonium chloride, that is a benzene ring bonded with N triple bond N and Cl. So that is the reaction with this aniline, that is a primary aromatic amine with nitrous acid. Aryl diazonium salts are resonance stabilized, and these resonance structures are their intermediate to obtain the variety of products. They are used to form different types of organic products which are not possible by regular chemical reactions. So this is a benzene ring containing N triple bond N. This is a benzene diazonium ion. Here this bond present in the aromatic ring, that is shifted between aromatic ring and nitrogen and forms double bond here. So actually double bond is not shown in this second resonance structure, that is a printing mistake. So this double bond, next double bond is shifted towards the positive charge in the aromatic ring. Then at para position there is a formation of positive charge. Then finally last double bond in the aromatic ring that also moves and forms the positive charge at ortho position. So positive charge at ortho and para position are formed. and double bond positions are changes in the last this resonance structure. So these are the different resonance structures which stabilizes this aryl diazonium ion. So that is about the reactions of amines. Thank you.